Hello everybody, welcome into another lesson. So today we are going to talk about factoring even power polynomial equations. So yesterday we did factoring by grouping, which primarily works on odd power polynomial equations. Today we're going to talk about even power polynomial equations. So here you have 16x to the fourth minus 1. If you look at this, doesn't this almost look like the difference of two squares? In fact, when you have even power polynomials such as to the, definitely the second because it's quadratic, but to the fourth, to the sixth, to the eighth, and so on, you can actually treat them like you would a quadratic equation. So let me show you what that's going to look like. We can basically treat this as the difference of two squares. So the square root of 16x to the fourth, well, that's just going to be 4x squared, right? You'd have 4x squared, and then you'd have a plus 1. And then, since this is the difference of two squares, you'd also have 4x squared minus 1. And if you FOIL these out, you would end up getting 16x to the fourth minus 1. So yes, we can indeed treat this as a difference of two squares. Now the 4x squared plus 1 we can't factor any further, but the 4x squared minus 1 we sure can. The 4x squared minus 1 is a difference of two squares, so what you end up with for your factorization would be 4x squared plus 1, that quantity, times 2x plus 1, that quantity, times 2x minus 1, that quantity. That would be the complete factorization of 16x to the fourth minus 1. So really, a lot of these today are going to take quadratic forms. Even though they don't start out quadratic, you treat them like they're quadratic. And those work on even powers. Alright, so what do we got next? We have x to the fourth plus 3x to the second plus 2. So we have been given x to the fourth plus 3x to the second plus 2. So yes, this equation's to the fourth power. That's the degree of the polynomial, but again, we can largely treat this like a quadratic equation. If you're going to factor this, this would factor into x squared plus 1, that quantity, times x squared plus 2. And if you FOILed this all out, you would end up getting x to the fourth plus 3x squared plus 2. And we can't factor these any further since these are the sum of two squares. Although in a few lessons from now, we will factor the sum of two squares. They're just going to have two imaginary factors. So you actually can factor them, but for now we're only interested in real numbers, just for now at least. So this would factor into x squared plus 1, that quantity, times x squared plus 2. And I got more. Alright, so let's see, I have x to the fourth minus 81. So I have x to the fourth minus 81. Well, this almost looks like a difference of squares, doesn't it? So let's break this down. This will break down into x squared plus 9, that quantity, times x squared minus 9. Alright, well, x squared plus 9 we can't factor any further, but we sure can factor x squared minus 9 further. That's a difference of two squares. So the complete factorization of this would end up being x squared plus 9 times x plus 3, that quantity, times x minus 3. So again, with the even powers, it's all about taking a quadratic approach to factoring them. And just like with quadratic equations, you're not going to be able to factor every polynomial equation. And in other lessons, we're going to have another method for dealing with those, but we're not dealing with that today. or even in the next lesson. But let's move on to the next one. I have about 6 more. All right. So I have 81x to the 4th minus 256. So I've been given 81x to the 4th minus 256. Again, it looks like another difference of squares, right? So take the square root of each term. Well, I would end up with the quantity of 9x squared plus 16. That's definitely not going to factor any further. And as a byproduct, I'd also get 9x squared minus 16. Right? So there's, if you treat this as a difference of 2 squares, well, the 9x squared minus 16 will factor further since that's also a difference of squares. So what you'll end up with is 9x squared plus 16, that quantity, times 3x plus 4 times the quantity of 3x minus 4. So that would be the complete factorization of 81x to the 4th minus 256. It would be 9x squared plus 16, that quantity times 3x plus 4 times the quantity of 3x minus 4. All right. Let's see. 4x to the 4th minus 5x to the 2nd minus 9. All right, so we have 4x to the 4th minus 5x squared minus 9 is this expression. It's a 4th power expression. We need to factor that. So let's see, what are some factors of 4? Well, we for sure have 1 and 4. We also have 2 and 2. For 9, well, you have 1 and 9. Well, actually, let's see. Your middle coefficient's negative, and your constant term is negative, so you're going to need 1 positive and 1 negative factor for the 9 for each one. So you'd have positive 1 and negative 9. You would have negative 1 and positive 9. Then you would have 3 and negative 3. And yeah, that's really all you would have. All right. So let's see what we got here. So let's see what we're going to multiply. I think if we multiply 4 times the 1, and then 1 times negative 9 and add those together, that'll give us the middle coefficient of negative 5. So this should factor into, let's see, x to the 2nd, that quantity, then we'd have 4x to the 2nd. All right, the 4 was multiplied by 1, so this would be plus 1. And then the 1 was multiplied by negative 9. So you'd have 4x squared minus 9. So you'd end up with the quantity of x squared plus 1 times the quantity of 4x squared minus 9. And if you FOIL all this out, you should get 4x to the 4th minus 5x squared minus 9. Now, of course, x squared plus 1 won't factor any further, but 4x squared minus 9 will, since that's the difference of 2 squares. So the complete factorization would end up being x squared plus 1 times the quantity of 2x plus 3 times the quantity of 2x minus 3. So here is your complete factorization of 4x to the 4th minus 5x squared minus 9. You should end up getting the quantity of x squared plus 1 times the quantity of 2x plus 3 times the quantity of 2x minus 3. Should have about 4 more. let's see, x to the fourth plus 10x squared plus 16. So we have x to the fourth plus 10x squared plus 16. Well, since everything's positive, I think it's going to be obvious that you would end up getting x squared plus 2, that quantity times x squared plus 8. And both of these are the sums of squares, so they don't factor any further. So there's the complete factorization. You would get x squared plus 2, that quantity times x squared plus 8. That one was easy enough. All right, I have about 3 more. All right, 81 minus 16x to the fourth. So we have 81 minus 16x to the fourth. Well, again, it looks like the difference of 2 squares, right? So if we go to treat this as such, you should end up getting 9 plus 4x squared, that quantity, times the quantity of 9 minus 4x squared. Well, 9 plus 4x squared clearly is not factorable because it's a sum of squares, but 9 minus 4x squared is factorable since it's a difference of squares. So what you should get is 9 plus 4x squared, that quantity times 3 plus 2x times the quantity of 3 minus 2x. All these 3 factors would be the complete factorization of 81 minus 16x to the fourth. I have about 2 more. Now, what if I gave you something like this? So we have 32x to the sixth minus 2x squared. All right, so we have 32x to the sixth minus 2x squared. Well, let's see what common terms these two have. There's definitely a 2x squared in common between both of those, right? So let's factor out 2x squared. So in your parentheses, you should end up then with 16x to the fourth. Then that'd just be minus 1. Well, so now you have 2x squared outside the parentheses. In the parentheses, you have what looks like a difference of 2 squares. So let's factor that as such. You would end up getting 2x squared times the quantity of 4x squared plus 1 times the quantity of 4x squared minus 1. Well, 4x squared plus 1 won't factor any further since it's a sum of squares, but 4x squared minus 1 will since it's a difference of squares. So this will factor even further into 2x squared times the quantity of 4x squared plus 1 times the quantity of 2x plus 1 times the quantity of 2x minus 1. So the complete factorization of this is going to be 2x squared times the quantity of 4x squared plus 1 times the quantity of 2x plus 1 times the quantity of 2x minus 1. And I got just one more. All right. Now they're throwing a little bit of a curveball at you. 6x to the fifth minus 51x to the third minus 27x. So we have 6x to the fifth minus 51x to the third minus 27x. Now it's true it's an odd power polynomial. However, what do all three of these terms have in common? They all have an x for sure, right? Definitely an x we can factor out. What else do they have in common? They also got a common 3. So really they have a 3x in common. So if we factor out that 3x, this will end up turning into 3x times the quantity of 2x to the 4th minus 17x squared minus 9. So now you have, inside the parentheses, you have a 4th power, which we can now treat like a quadratic. And then let's figure out some factors of 1 and 2. And then since your middle coefficient is negative for the x squared and your constant term is negative, you need a positive and a negative factor of each that'll work. So what are there for 9? For negative 9, I should say. You have positive 1 and negative 9. You have negative 1 and positive 9. And then you have positive 3 and negative 3. And that's really all there is. That's all there are. Well, let's see. If I take 2 times negative 9 and then add that to 1 plus 1, I should get a middle coefficient of negative 17. So this should turn into 3x times the quantity of x squared. And then that's for your first quantity. You'll have a 2x squared in your next quantity. Alright, so 2 was multiplied by what? Negative 9, so you'd have x squared minus 9. 1 was multiplied by 1. Alright, so this breaks down into 3x times the quantity of x squared minus 9 times the quantity of 2x squared plus 1. So the 4th plus x squared minus... Yep. Alright. Well, the 2x squared plus 1 is definitely, it's a sum of 2 squares, so that's not going to break down any further. But x squared minus 9 will break down further because that's a difference of squares. So the complete factorization would end up being 3x times the quantity of x plus 3 times the quantity of x minus 3, all that times the 2x squared plus 1. That would be the complete factorization of the original polynomial. You would get 3x times the quantity of x plus 3 times the quantity of x minus 3 times the quantity of 2x squared plus 1. So now we have seen how we would factor even power polynomials, and now we've actually seen every trick for factoring polynomials, whether they're even or odd power, which odd power involves factoring by grouping. We've seen also factoring out common terms in general. So yeah, we've done all the factoring now for polynomials. So the next lesson, we're going to combine all these methods and we're actually going to solve polynomial equations. So we're going to be given polynomial equations. It's up to you to determine which method is the best to use to solve it. So I hope everyone has a great day. Take care.